Hello there, and welcome once again to Science for Sleep, the place where curiosity winds down with you at the end of the day, where questions about the universe drift as softly as the breath before sleep. Tonight, I'd like to invite you into one of the most mysterious regions ever imagined, a place so far from the warmth of our sun that it's more myth than map. It's called the Oort cloud, and some astronomers suggest it may be the real boundary of our solar system. Others wonder if it's not just the edge of the system, but something stranger, a threshold where the idea of reality itself begins to blur. Before we settle in, let me ask you something simple. Where are you listening from tonight? And what's the time on the little clock in your corner of the world? I always find it grounding to think that while one person may be hearing this during the quiet stretch of midnight, another might have the golden haze of evening still clinging to their window, and someone else may be starting their morning, already sipping their tea or coffee. A topic about the edge of reality, yet we're each sitting in our own present moment, scattered across the globe, connected by nothing more than a voice and a bit of curiosity. If you find yourself enjoying this calm exploration, if the thought of letting science settle you toward rest appeals to you, I'd be grateful if you chose to like this little corner of the internet and perhaps subscribe. It helps more than you might think. And more importantly, it helps other people, maybe people who need something steady and gentle tonight, to find their way here too. So now, let's dim the pace of the day. Let's imagine we're lying back beneath an endless dome of stars, the world quieter than usual, and let's begin our drift outward. The Oort cloud is at first glance not even something you can point to. No telescope has ever photographed it. No spacecraft has ever flown through it. It's more an idea than an image. A kind of invisible sphere of icy fragments that supposedly stretches nearly a light year away from the sun. Astronomers believe it exists because of the way comets arrive at us from every direction as if they were shaken loose from a gigantic, all-surrounding reservoir. When we see a comet sweep across the sky, we may be seeing a visitor from this unseen halo, a tiny messenger from a place so distant that sunlight itself is only a faint whisper. But I don't want to jump too quickly to distances and numbers. Before we think about how far the Oort cloud might be, or how thinly its frozen pieces are spread, it's worth slowing down and imagining what it means for there even to be an edge. Our solar system feels so big already, doesn't it? Planets circling in their endless orbits, moons dancing around them, asteroids scattered like crumbs across the dark. And yet all of that from Mercury to Neptune, from Saturn's rings to Pluto's lonely track, is thought to be just a small inner zone compared to the vast halo that may extend beyond. When Oort, the Dutch astronomer, first proposed the existence of this cloud in 1950, it was an elegant way to explain a puzzle. Comets keep appearing. Some have orbits that bring them back around the sun again and again, like Hall's Comet. Reliable, if a bit dramatic. But others arrive once and vanish into the deep, never to be seen again. Where did they all come from? Why weren't they exhausted long ago? The answer suggested was that an enormous reservoir must exist, filled with trillions of icy bodies, each waiting in silence until something nudges it inward. A passing star, the gentle tug of galactic tides, perhaps even the echo of ancient collisions. Whatever the cause, one of these icy fragments is jolted into a new trajectory, beginning a long, slow fall toward the light, melting and brightening as it approaches, briefly dazzling us before retreating back into obscurity. If that's true, then the cloud is more than a distant belt of debris. It's the invisible skin of our solar system. It's the part of us that brushes up against the wider galaxy. Imagine Earth as your home, the planets as your neighborhood, the Kuiper Belt as the city limits. The Oort cloud would then be like a faint outline of countryside, a wilderness that encircles the whole settlement and blurs gently into the forests of other towns. In that sense, the Oort cloud is not just a structure. It's a borderland, and borders always invite questions. Does what lies beyond belong to us, or does it belong to something else? Is there even such a thing as an edge, or is the universe more like an unbroken continuum where boundaries are just our own invention? And here in this thought lies why so many people feel a strange pull when they first hear about the cloud. It's not just a scientific curiosity, not just a cluster of cold fragments. It's a symbol of the unknown, a ring of mystery sitting just far enough away to remain untouchable, yet close enough that it belongs in some sense to us. Think of how often edges in our lives take on that same aura, the edge of the sea where the land stops and the waves begin. the edge of childhood when memory becomes sharper and we suddenly realize we're part of a bigger story. The edge of sleep where you're right now perhaps drifting between awareness and dreaming. Each edge feels like both an ending and a beginning, and the Oort cloud offers that same feeling on a cosmic scale. As we picture it, imagine the faintest light of the sun, a dot so distant that even daylight would feel no stronger than the glow of a bright star. The comets out there are frozen to the core, undisturbed for billions of years. Some of them might have been drifting in the icy solitude since the very birth of the solar system. Never once warmed by the inner sun, never once melted, preserved like time capsules. To hold one in your hand would be like shaking hands with the dawn of planets. But of course, no one has gone there. No one has brought back a fragment of the Oort cloud. It is, in a sense, the most human kind of place, imagined, inferred, pieced together from evidence. We see the traces of its existence only when something escapes from it. Like shadows hinting at an unseen structure, the comets are the footprints left behind by this great invisible herd. And so here at the beginning of our exploration tonight, we find ourselves not at the cloud itself, but at the threshold of imagination. To talk about it is already to acknowledge the edges of what we know, the points where evidence blends with theory. Yet, that's not a weakness. It's part of the magic of science. Your cloud, whether exactly as we imagine or slightly different, reminds us that the universe is not finished revealing itself. As you lie here listening, you might find yourself wondering what it would feel like to actually travel outward, to leave behind the warmth of Earth, the familiar paths of Mars and Jupiter, and keep going past the asteroids, past the realm of Neptune, into the thin belt of the Kuiper objects, and then further still until the sun begins to shrink behind you. Days and nights would lose meaning, for there would be no sunrise anymore. Only the faint glow of a faraway star. Your star, still yours, but already fading into background. Eventually the darkness would deepen so much that only the distant constellations would keep you company. And somewhere out there, surrounding you on all sides, the first grains of the Oort cloud would begin to appear, scattered like invisible dust motes in an ocean of a night. That is where our journey is heading. But for now, let's rest in the thought of it. Let's carry with us the idea that perhaps the edge of reality is not something abrupt, not a cliff or a wall, but a gradient, a soft fading, the way the colors of twilight melt into night. When you hear the words Oort cloud, it can sound almost like a phrase from mythology, as if it belongs alongside stories of ancient gods or whispered legends of hidden realms. In a way, that isn't far from the truth, because what we call the Oort cloud is not something we have ever directly seen. No spacecraft has sent back a photograph of it, and no telescope has captured a picture of its icy borders. Instead, it lives in the space between evidence and imagination. A scientific legend born not from myth but from mathematics and the careful noticing of patterns. And like many legends, the more you linger on it, the more it grows into something larger than itself. The Oort cloud is thought to be a vast spherical shell of icy bodies that surrounds our solar system in every direction. A halo that might stretch almost a light year away from the sun. To give you a sense of how immense that is, think of Pluto, the little outpost planet we once considered the 9th member of our solar family. Pluto orbits at about 40 times the distance between Earth and the sun. The inner edge of the Oort cloud is believed to begin thousands of times farther out than that. If Pluto were a neighbor just a few houses down the street, the Oort cloud would be like a countryside so distant you'd need months of travel just to reach the first fence. What makes this halo so fascinating is that it changes the way we think about the solar system. When most of us picture our home in the cosmos, we imagine the planets circling in a flat disk, the sun blazing at the center, and perhaps a belt of asteroids somewhere in between. But if the Oort cloud is real, and most astronomers believe it is, then the solar system is not just a flat disk. It is wrapped in a giant shell, a three-dimensional sphere that encases everything we know. That changes the geometry of our mental picture. It turns the solar system from a platter into a bubble, from something spread thin into something fully enclosed. This sphere is thought to contain perhaps trillions of icy fragments, ranging in size from tiny grains to mountains as large as small planets. Each one is a frozen leftover from the early days of planet building when the sun was young and the planets were still forming. Some pieces may be rich in water ice, others in carbon compounds, others perhaps in exotic mixtures we have never touched. To imagine standing on one of them, if such a thing were possible, would be to feel silence so deep it would ring in your ears. A darkness so perfect it would make even the stars look bright and close. You would see the sun as nothing more than a distant star, indistinguishable from thousands of others scattered across the sky. And you would know that you were still technically part of the solar system, yet already on the doorstep of interstellar space. But how did these icy fragments get there in the first place? The story, as scientists reconstructed, begins billions of years ago when the solar system was still a swirling disk of dust and gas. Out of this disk, planets condensed, pulling material together under the steady hand of gravity. But not all of that material stayed neatly close to the planets. Some of it was flung outward by gravitational encounters, tossed like pebbles from a sling. Over time, enough of these scattered fragments settled into elongated orbits, drifting farther and farther away until they formed a kind of distant, diffuse cloud. Like crumbs scattered around a kitchen after baking bread, these icy bodies became the leftovers of creation, no longer bound to the warmth of the inner system, yet still held by the faint but persistent gravity of the sun. Astronomers suspect that the Oort cloud is not a dense swarm, not something you would see as a solid wall if you could approach it. Instead, it is more like a vast emptiness sprinkled with occasional objects separated by enormous distances. To picture it, you might think of standing in a desert at night. Grains of sand spread across the ground beneath a sky filled with stars. Each icy body in the cloud is like one of those grains, small, far apart, and surrounded by endless dark. Yet together, they add up to a structure that defines the boundary of our solar system. We know of its existence not because we have touched it, but because we see its fingerprints. Long-period comets, those that sweep in from far beyond Neptune and then disappear again for thousands of years, betray the presence of a reservoir that feeds them. Their orbits are scattered in all directions, not aligned like the planets or even like the Kuiper belt. That randomness suggests a spherical source, and the simplest explanation is a great surrounding cloud. Oort, who first proposed it, did so after carefully studying the paths of comets, noticing patterns that made no sense unless they originated in a distant sphere. His insight reshaped our cosmic map, reminding us that what we cannot see may be just as real as what we can. In some ways, this makes the Oort cloud one of the purest examples of human imagination grounded in science. We cannot point a camera at it. We cannot yet send a probe. And yet, by tracing the arcs of icy travelers, by watching how gravity tugs and pulls, we build a picture of something invisible. It is as if we were mapping a forest, not by walking through it, but by catching glimpses of birds that fly from its edges. From their flight paths, we infer the shape of the trees, the depth of the woods, the presence of something more. That idea alone has a kind of quiet beauty, because the Oort cloud shows us how science often works. We don't always see directly. Sometimes we listen for echoes. We notice footprints. We connect patterns. And from those patterns, we draw out the shape of hidden realities. In that sense, the Oort cloud is not just a physical place, but a lesson in perception. It also reminds us of scale. The distances involved are almost impossible to imagine. Voyager 1, the most distant human-made object, has been traveling outward since 1977. It has crossed into interstellar space, yet by most estimates, it hasn't even reached the inner edge of the Oort cloud. At its current speed, it might take another 300 years just to get there, and tens of thousands of years to cross through it entirely. That means the cloud is not just far away. It is unimaginably vast, so large that human exploration of it is something we can only dream of, not yet planned for. And yet it may be the region that most fully defines where our solar system ends and the galaxy begins. To call it a halo feels appropriate because a halo is something that surrounds, something that crowns, something that hints at significance. The Oort cloud is our solar halo, a borderland of ice and silence that both protects and hides. It is thought that most of its objects are stable, content to drift for billions of years without disturbance. But now and then, a disturbance comes, and that's when a comet is born. A passing star, a subtle pull from the galaxy itself, a chance encounter can send one of these icy travelers inward. And when that happens, we see it. It brightens in our skies, it grows a tail, it becomes a spectacle. And then it reminds us that every comet we have ever seen, every streak of light that has sparked wonder in human eyes, may have begun its journey in this invisible halo. It is strange to think that the stories we tell about comets, omens, portents, symbols of change are really stories about the Oort cloud. Because those comets are its emissaries, the only visible pieces of it that we ever glimpse. When ancient people looked up and saw a comet blazing across the sky, They were, without knowing it, witnessing a fragment of the halo. They were seeing the farthest edge of the solar system made visible for a moment. In that way, the Oort cloud has been part of human imagination long before we had a name for it, long before Oort put it into equations. And so, as we rest in the thought of this halo, it becomes not just a scientific concept, but a symbol of distance, of boundary, of hidden things. A reminder that even our home system, familiar as we might feel about the planets and their orbits, is still wrapped in mystery. If the Oort cloud is a halo, a great surrounding shell of frozen fragments, then it leads us naturally to a question that is both simple and unsettling. Where does the solar system end? We talk about edges and borders as if they're lines on a map, clear and sharp. But when you try to draw such a line in space, it refuses to stay still. It blurs, it fades, it stretches. What seems like a border one moment becomes a region the next, and what feels like an ending often leads seamlessly into something else. For much of human history, the solar system was only as big as the eye could see. The ancients looked up, saw the bright wanderers moving against the backdrop of the stars, and called them planets. Beyond Saturn, there was nothing visible, nothing that could be tracked without instruments. The edge of the solar system was Saturn itself, a ringed giant glimmering at the horizon of human imagination. It took centuries, telescopes, and persistence to reveal more, to discover Uranus, Neptune, and finally Pluto. Each new discovery pushed the boundary farther, redrew the edge, stretched the map. And even now, when we have sent probes beyond Pluto, the question of where the solar system truly ends remains unsettled. There are several ways to define it, each with its own logic. One way is by the reach of the sun's gravity. Gravity is what holds the planets in their orbits, what keeps comets tethered, what binds the system together. But gravity never really stops. It weakens with distance, fading into smaller and smaller pools. But it doesn't vanish. Even trillions of kilometers away, the sun still exerts a faint tug. By that measure, the solar system never ends at all. It stretches forever with the sun's gravity reaching across infinite space. Another way is by the reach of the solar wind, the stream of charged particles that flows outward from the sun in every direction. This wind forms a bubble called the heliosphere around the solar system. Inside it, particles from the sun dominate. Outside it, particles from the wider galaxy begin to take over. The boundary where the solar wind slows and collides with interstellar space is called the helop, and this is sometimes called the true edge. Voyager 1 crossed it in 2012 after 35 years of travel, making it the first human artifact to leave the solar bubble. Yet, even beyond the helipore, the sun's gravity still extends, still binds the Oort cloud. So, which edge is the real one? The edge of influence or the edge of wind? Then there's the Oort cloud itself. If it exists as we imagine, then it might be the best candidate for the outer limit of the solar system. Objects in the Oort cloud are still loosely tied to the sun's gravity, still part of the solar family, yet they are so distant that the galaxy itself has almost equal claim to them. It's a liminal region, a twilight zone where the pull of the sun and the tug of the stars compete. Some astronomers consider the farthest reaches of the Oort cloud to be the practical end of the solar system, because beyond that, the influence of the sun is simply too weak to dominate. Beyond that, an object belongs more to the galaxy than to the sun. But even here, the word end feels misleading because the solar system doesn't stop like a road hitting a wall. It fades, it thins, it becomes gradually less certain like the shoreline of an estuary where river meets sea. Imagine standing at that shoreline. On one side, the fresh water of the river flows. On the other, the salty ocean stretches away. But between them, there is a zone where the two mix where it's hard to say where one ends and the other begins. The solar system is like that. It doesn't terminate, it blends into the wider galaxy. This blending invites strange questions. If you could somehow travel outward, leaving Earth, passing Mars, drifting past the gas giants, sailing beyond Pluto, and finally reaching the scattered disk and Kuiper belt, would there ever be a moment when you could say definitively, "Now I have left"? Probably not. There would be no cosmic signpost, no sudden transition. Instead, there would be gradual changes. The density of solar particles would drop. The comets would grow rarer. The sun would shrink into a background star. And eventually, the stars of the galaxy would begin to claim more of your attention than the faint pull of the sun. Even Voyager 1, as it crossed the helipore, experienced no sudden jolt. Instruments detected a shift in particle density, a change in the magnetic field. But to a human traveler, the view would have been the same. darkness, stars, a distant sun. The boundary is scientific, not experiential. You can measure it with instruments, but you cannot feel it. And perhaps that's what makes the idea of an edge so compelling. We long for borders, for lines that mark beginnings and endings. But space teaches us that most borders are gradients, most endings are transitions. The question of where the solar system ends also touches on philosophy. Because if we can't point to a line, then what does it mean to belong? Does the Oort cloud belong to the solar system, or does it belong to the galaxy? If an object drifts for billions of years on the edge, perturbed by passing stars occasionally nudged inward, is it ours or is it shared? These questions mirror the way we think about ourselves. Where do we end? And where does the world begin? Are we defined by our skin or by our interactions, our influences, our ties? The Oort cloud in this sense is a metaphor for identity as much as it is a scientific region. Consider, too, that what we call the end of the solar system may depend entirely on what we're measuring. For some scientists, the edge is defined by radiation, for others by magnetic fields, for others still by gravitational binding. Each perspective is valid, yet none is final. The solar system, like reality itself, resists neat labels. It stretches beyond the categories we try to place on it. There is also the question of interstellar visitors. In recent years, objects like Oumuamua and Comet Boris have been detected passing through our system. They came from beyond, from the interstellar void, crossing through our sun's domain before slipping away again. Their presence reminds us that the boundary is porous. Things do not simply stay inside or outside. They cross, they wander, they blur the line. The solar system is not an isolated island. It is an archipelago in a sea of stars, and its edges are constantly lapped by galactic tides. Imagine for a moment that you were on one of those interstellar travelers, a fragment of rock or ice born in another system set adrift by a gravitational encounter eons ago. You drift for millions of years, perhaps billions, until finally you approach the faint glow of a distant star. Its gravity tugs you, its light brushes your surface, and for a time you pass through its domain. Then, just as quietly, you continue on into the void, carrying with you no sense of edges, no map of borders, only endless night. From the perspective of such an object, the idea of where one system ends and another begins is meaningless. There is only travel, only drifting, only change. And yet for us, the question matters because we want to know where we are. We want to know what belongs to us and what lies beyond. We crave the comfort of maps, even when the universe refuses to be mapped neatly. Perhaps the U-cloud is not just a scientific structure, but a reminder that edges are often illusions. They're useful illusions necessary for navigation and understanding, but still illusions. The truth may be that the solar system does not end. It simply dissolves into the galaxy, and the galaxy itself may dissolve into larger structures, each boundary fading into the next. Still, when we speak of the edge of the solar system, we are really speaking of a region where our influence gives way to something larger, where the familiar gives way to the unknown, where the story of the planets yields to the story of the galaxy. It is a place that symbolizes transition, and transitions are always powerful. They remind us that nothing has fixed, that all things are in motion, that endings are beginnings in disguise. The Oort cloud embodies this truth. It is the place where the solar system does not end, but rather hands itself over to the galaxy, where the identity of our system becomes porous, where belonging becomes shared. When we think of the Oort cloud, it can feel almost too abstract, too far away to hold on to. But there are visitors that come to us from that region, reminders that the distant halo is real, even if invisible. These visitors are comets, the icy messengers that cross the void and blaze through our skies. In a way, every comet is a letter delivered from the edge, a message written in ice and dust that tells us something about where it came from and what it has endured. Comets are among the oldest objects in the solar system. Their cores are thought to be leftovers from the early days of planet formation, frozen relics that never grew large enough to become planets or moons. For billions of years, they have drifted in the cold, preserving within the materials that date back to the birth of the sun itself. When one of them is nudged from its distant orbit and begins its long fall toward the inner solar system, it carries with it those ancient ingredients locked away until sunlight sets them free. The journey of a comet is slow at first. Imagine a fragment in the Oort cloud, resting in the deep cold, far beyond the warmth of any star. For countless millennia, it drifts quietly, pulled slightly by the faint tug of the sun, but otherwise untouched. Then, perhaps because of the subtle pull of a passing star, or the collective influence of the galaxy's tides, its orbit changes just enough to set it on a path inward. At first, the change is imperceptible. The comet may take millions of years just to cover the first fraction of the distance, but as it falls closer to the sun, gravity strengthens, speed increases, and the slow drift becomes a plunge. As it nears the inner solar system, something remarkable happens. The sunlight, which was once just a faint glow on the horizon, becomes warm enough to awaken the comet. Ices that were stable for billions of years begin to sublimate, turning directly into gas. Dust trapped within the ice is released, creating a haze around the solid core. This haze, called the coma, can be thousands of kilometers wide, a ghostly atmosphere surrounding a nucleus, often no larger than a mountain. As the solar wind catches the gas and dust, it stretches them out into a tail that always points away from the sun. That tail can be millions of kilometers long, a luminous brushstroke across the night sky. From Earth, such a sight can be breathtaking. Throughout history, comets have appeared suddenly, often brighter than the stars, moving perceptibly night by night. For ancient people, they were both wondrous and terrifying, omens of change, symbols of upheaval. Kings feared them, poets described them, astronomers tried to chart their paths, and yet what they were truly seeing was something deeply ordinary and deeply profound at the same time. An icy fragment of the solar system's beginnings, lit up by the warmth of the star we call home. Not all comets come from the Oort cloud. Some belong to the Kuiper belt, closer in, a region beyond Neptune filled with icy bodies. These comets tend to have shorter orbital periods, circling back around the sun every few decades or centuries. Hall's Comet, for instance, is one of these. It has been recorded for thousands of years, appearing roughly every 76 years, returning reliably enough that it can be predicted. But the long-period comets, the ones that might take thousands or even millions of years to return, those are the ones that likely come from the Earth cloud. They can appear from any direction, their paths tilted and scattered, arriving like strangers with unfamiliar accents. Their very randomness betrays the presence of the vast spherical reservoir surrounding us. In that sense, comets are the only direct evidence we have of the Oort cloud. We cannot see the cloud itself, but we can see its ambassadors. Each comet that flares through the sky is proof that the halo exists, that the solar system is not just a disk of planets, but a sphere with icy edges. To watch one is to witness the invisible made visible, the distant made tangible. There is also something poetic about the way comets live two lives. In the Oort cloud, they are silent and dark, frozen time capsules drifting without witness. But when they enter the inner solar system, they become luminous, dramatic, impossible to ignore. They are both introverts and extroverts, hidden for eons, spectacular for weeks, and then just as suddenly they fade again, retreating back to the silence. It is as if they were born to remind us briefly of the vastness we cannot see before disappearing again into it. Scientists study comets not only for what they reveal about the Oort cloud, but also for what they reveal about ourselves. Some theories suggest that much of Earth's water may have originally come from comets delivered in the planet's youth during a time of heavy bombardment. Others propose that comets may have carried organic molecules, the chemical seeds of life, to our world. If that is true, then the Oort cloud is not just the edge of the solar system. It is part of the story of why we're here at all. To think that the water in your glass or the molecules in your cells might once have been locked inside an icy fragment drifting on the farthest edge of the system is to feel a connection that stretches across billions of years and trillions of kilometers. But comets are also reminders of fragility. Their paths can be unpredictable. They can collide with planets, as happened with Jupiter in 1994, when fragments of comet Shoemaker-Levy 9 slammed into its atmosphere, creating scars larger than Earth itself. Such impacts remind us that comets are not only messengers but also hazards capable of reshaping surfaces, altering climates, and changing histories. In the past, impacts from comets or asteroids may have played roles in mass extinctions on Earth. The dual nature of comets, bringers of water and life, bringers of destruction, gives them a mythic weight. They are both creators and destroyers, gifts and warnings. Even so, there is a quiet dignity in their journeys. To imagine a comet's orbit is to imagine patience beyond measure. A single trip around the sun might take longer than all of recorded human history. For a comet, centuries are the blink of an eye. Millennia are routine. They are travelers whose timescales dwarf our own. And yet, we notice them because they happen to flare in our skies during our brief lifetimes. It is a reminder that the universe is full of stories unfolding on timescales so vast, we can only glimpse fragments of them. When you next think of the Oort cloud, it may help to think of it not as an empty abstraction, but as the silent birthplace of comets. Each streak of light across the sky, each glowing visitor that leaves us staring upward in wonder is part of its legacy. Comets are the proof that the edge exists, that our solar system does not fade into nothing but extends into a halo of frozen messengers. They carry the memory of the beginning. They travel through the present and they hint at futures we can scarcely imagine. And as we lie here thinking about them, it is worth remembering that some of those comets are already on their way inward right now, falling slowly toward the sun. They may not arrive for centuries, perhaps millennia, but their journeys have begun. And one day, someone will look up and see them just as people have for thousands of years. The cycle will continue. The messages will keep arriving. A